Homogeneous differential equation. If differential equation of form dy by dx is equal to f of xy divided by g of xy. Operator is separated in term of x and y, where term of x and y, f of xy, g of xy are homogeneous terms. As homogeneous means the expression having the terms of equal degree, like x square plus y square plus 2xy, or x cube minus 3x square y plus 4xy square minus y cube, or 3x plus 4y. These are called homogeneous terms. As you observe, in each term of expression is in first, the degree of term is a 2. As first term x square has a degree 2, y square has a degree 2. In third term x has a degree 1, y has a degree 1, and total term is the addition of power, that is 2. Similarly, in second example, each term has a degree 3. In last, actually these are the term of linear, term of x and y. So these are homogeneous. If I add here one constant 7, then this is not homogeneous. This is called non-homogeneous expression, as the first term has a degree 1, second term has a degree 1, as a constant in third has a degree 0. So degree of each term is not equal. If I put here only 2x, then this expression is a non-homogeneous. So understand the difference between homogeneous and non-homogeneous terms. Now, if the given expression contain given differential equation is in term of x and y, homogeneous term of x and y, such a equation is called homogeneous differential equation. Okay, as you understand, first variable separable differential equation. Now homogeneous and variable separable are two different type of differential equation. In variable separable, you understand, you learn the terms of x and y are explicit, or if they are together, then they are in multiplication or division. But in homogeneous, term of x and y are in addition or subtraction, but the degree of each term should be equal. To solve such a differential equation, we have a standard putting y is equal to ux. As you learn in reducible to variable separable differential equation, you put the terms of y into you can put term in differential equation. In homogeneous, you have to put y is equal to x, and you have to change the operator. For that, we take the differentiation of y is equal to ux, as derivative of y with respect to x is a dy by dx, but u into x is a product, as u is a variable, x is a variable, both has derivative. So first u constant, derivative of x with respect to x is a 1, plus x is the second term, take constant, and in product, derivative of u with respect to x is a du by dx. So if the given differential equation is homogeneous, that means dy by dx in term of homogeneous terms of x and y, then in such a differential equation we have to put y is equal to ux and dy by dx is equal to u plus x into du by dx to solve the differential equation. These are some examples which are homogeneous differential equation. As you observe, some of them are given in standard form of homogeneous, that is dy by dx is equal to f of xy divided by g of xy. As you observe, the first example is in standard form, as dy by dx are separated into term of homogeneous term of x and y. As you observe, in numerator there is a term of x and y in addition, as in denominator they are in product, but power of each term is 1 1. So power degree of denominator term is a 2, as numerator has a term of degree 2. So these are homogeneous terms of x and y. So this is a homogeneous differential equation. As in second term, you can observe this is not in standard form, though the terms are in addition on right hand side, term of x and y. So this differential equation could not be a variable separable, as in variable separable terms of x and y are always in product or in quotient. But here the term of x and y are in addition, as the degree of each term is a 2. On left hand side, x and y is in product though, but degree of this is also 2. So this is a homogeneous. As you can similarly in third and fourth example, you can define these are homogeneous differential equation. Now we have to solve the differential equation. The first differential equation, as you have given here, dy by dx is equal to x square plus y square divided by 2xy. As put this as a number 1 always, as we have to put in this differential equation y is equal to ux. This is a standard substitution. To put dy by dx, we have to differentiate this with respect to x, as y has a derivative dy by dx. On right hand side, u into x is a product, so by taking product rule, u is a constant, derivative of x is always 1, plus x into derivative of u with respect to x is du by dx. So equation 1 becomes as dy by dx. On left hand side we put u plus x into du by dx, and on right hand side we have to put y as ux. Now in numerator, first term is x square as it is, plus y square, as y is equal to ux, so y square is equal to u square x square, s y square, so we have to put u square into x square, and in denominator 2x as it is, and y as we put into bracket ux. Now simplifying this, as numerator has a common x square in both terms, so we put x square into bracket, we have 1 plus u square, and in denominator, as 2x is multiplied with respect to x, we get 2x square into u. As x square are in common in numerator and denominator in product, so get cancelled, and we get simple terms of u, as in numerator 1 plus u square and denominator is equal to u. So we have simplified this. Now we have to solve this differential equation. We reduce this into variable separable. As you can observe, term of u is in left hand side, we take it into right hand side, and on left hand side we remain x into du by dx. On right hand side 1 plus u square divided by 2u is subtracted with u. Okay, now we take subtraction, simple subtraction, as on right hand side we have to make common denominator, so we multiply denominator of first term 2u with numerator of second term, that is u, so we get 1 plus, actually I have put here as a 1 plus u square minus u into 2u minus 2u square divided by common denominator, we get 2u. Now 1 plus u square minus 2u square gets cancelled, we get 1 minus 2u square divided by 2u. Or on left hand side we have x into du by dx. Now to separate term variables, we take the term of u on left hand side, as du is in numerator on left hand side, and dx take on right hand side, so x should be transferred on right hand side also. So 2u take in numerator as 1 minus u square in denominator multiplied by du, and on right hand side x take in denominator, as x is in numerator on left hand side and dx in a multiplication or in numerator. So take integration to solve differential equation, as on left hand side we get term of u in integration with respect to u, and on right hand side we get 1 upon x into dx. Now you can observe denominator is 1 minus u square has a derivative, 1 has a derivative 0, and u square with respect to u has a derivative 2u, but subtraction is a sign, so denominator of 1 minus u square with respect to u has a derivative minus 2u, as we have to adjust minus sign in numerator only, so minus 2u in numerator, in integration denominator divided by 1 minus u square into du, integration on right hand side 1 upon x, as you can form here for f dash x upon f of x. As you know, it is standard integral form and it has integration log of denominator, so 1 minus u square has a derivative minus 2u in numerator, so integration of this fraction is a log of denominator, that is log of 1 minus u square, and on right hand side as a 1 upon x as integration log of x plus c. Now you have to resubstitute the value of u, as you put y is equal to ux. From this you can define u as take x on denominator of y, so u is equal to y upon x. So by putting u is y upon x in solution, we get minus log of 1 minus, as u is equal to y upon x, u square is equal to y square upon x square, as on right hand side as log of x plus c, and this is the solution. xy dy is equal to x square plus y square. As you can observe here, this is not in standard form though. Implicit term of x and y having equal degree containing, so we can take dx on left hand side, so we get dy by dx is equal to implicit term of x and y on right hand side having same degree. So this is a homogeneous differential equation. As we put this as 1 and put y is equal to ux in equation, to find operator value of dy by dx, take differentiation on with respect to x. As on right hand side you get product rule, by applying it we get derivative as u into u plus x into du by dx. Now equation 1 becomes on left hand side as dy by dx is equal to u plus x into du by dx, and on right hand side as y is equal to ux in numerator, as x square remain as it is and y square become u square into x square. As in denominator we get product of x into ux. Now taking x square as a common in numerator we get in bracket 1 plus u square, and in denominator x into x square into u. As x square is in common numerator in product, so get cancelled, and we take term of u on right hand side. As we have to reduce this in variable separable, we take left hand side u which is in addition to right hand side. So we get on left hand side x into du by dx, and on right hand side 1 plus u square divided by u get in subtraction with u. By simplification, to simplify we take cross multiplication. As on right hand side we get 1 plus u square as the first numerator, and in second numerator u into u get minus u square, as denominator is remain u, as u square get cancelled as plus minus, and we get 1 upon u and on right hand side. Now as on left hand side we have x into du by dx, term of x and dx transfer on right hand side, and this term of u take on left hand side. As it is in denominator on right hand side, we take it in numerator or product, or in product with du, and on right hand side we have 1 upon x into dx. To solve we have to take only integration. So integration of left hand side u with respect to u, and on right hand side integration of 1 upon x. As u is a power term, so its integration is u square by 2. On right hand side integration of 1 upon x is a log of x plus c. And finally we have to resubstitute. As y is equal to ux, we get u as a y upon x. So finally y upon x or y square upon x square divided by 2 is equal to log of x plus c. By dx minus x cube plus y cube dy. As you can observe, x cube plus y cube is the implicit term, so this is not variable separable, but this is not in standard form of homogeneous, as degree of each term is 3, as x square plus x square has the power 2, y has the power 1, so degree of this term is 3, and these two terms has also degree 3, so this may be converted into homogeneous. For that we separate first operator on both sides. As minus term get on left hand side, it become positive. Now as we form dy by dx, so we take dx on right hand side and this bracket on left hand side in denominator. So on left hand side we get x square y divided by x cube y cube. On right hand side we get dy by dx. Now we have a differential equation dy by dx in term of homogeneous term of x and y. So this is a homogeneous differential equation. Put it as a number 1, and in difference to solve we have to put y is equal to x, which is differentiated with respect to x, as dy by dx is equal to u plus x into du by dx. So equation 1 becomes now on left hand side u plus x into du by dx, and on right hand side as y is equal to ux, in numerator we get x square, in bracket y as the ux, in denominator as x cube is the first term, and in second term y cube become u cube x cube, as y is equal to ux, so y cube is equal to u cube x cube. Now in numerator we have x square into x cube into u, and in denominator x cube is a common, so we get bracket 1 plus u cube. Now x cube get cancel as it is common in numerator and denominator, so we get on right hand side only term of u as u divided by 1 plus u cube. Now to reduce this differential equation in variable separable, first we take u on right hand side, so on left hand side we get only x into du by dx, and on right hand side u divided by 1 plus u cube subtracted by u. By simplification we take cross multiplication, as first term numerator has a u and second term numerator is multiplied with denominator of first term, minus u into 1 minus u, and minus u into u cube minus u raised to 4, as denominator as a 1 minus 1 plus u cube. Now u minus u get cancelled, and we get term of u on right hand side as u raised to 4 divided by 1 plus u cube. Now to separate variables, so we take term of u on left hand side as du on left hand side and x on and dx on right hand side. So we get 1 plus u cube divided by u raised to 4 into du, and on right hand side as minus sign is there, 1 upon x into dx. Now we have to take integration to solve the differential equation. Now taking integration on left hand side, 1 plus u cube divided by u raised to 4 du, and on right hand side minus take outside and integration in 1 upon x dx. Now to simplify this, this is a rational fraction, so I separate common denominator to get two terms in addition in right hand side, as first term 1 plus u raised to 4 and second term u cube divided by u raised to 4 into du minus 1 upon x dx on right hand side. Now this is a simple terms as 1 upon u raised to 4, as we know power terms are taken to numerator by changing the sign of index, that is u raised to 4 in denominator become u raised to minus 4 into numerator, and in second term u cube divided by u raised to 4 as get 1 upon u, as power get subtracted 4 minus 3, we get 1 upon u in denominator into du, and on right hand side we have 1 upon x dx in integration. Now take the integration only, as u raised to minus 4 is the integration of power, by adding plus 1 in index, we get integration as u raised to minus 3 divided by minus 3, plus 1 upon u is a standard form, as 1 upon x has the integration log x, 1 upon u has the integration log of u, and on right hand side minus 1 upon x has integration log of x plus c. Now finally you have to put value of resubstitute value of u, as y is equal to ux, u is equal to y by x. So the answer of this differential equation will be y by x bracket raised to minus 3 divided by minus 3 plus log of y by x is equal to minus log of x plus c. Do the simple step last. Okay. Y square plus x square dy by dx is equal to xy dy by dx. As you can observe, there are two terms of dy by dx. To find the form of this differential equation, we first simplify, as the term of dy by dx we take on right hand side, so plus x square become minus x square dy by dx. By taking dy by dx common from these two, we get xy minus x square in bracket into dy by dx. Now this bracket take on left hand side, it came into denominator of y square, so y square divided by xy minus x square is equal to dy by dx. Now you can clearly define this is a homogeneous differential equation, as dy by dx is separated into homogeneous terms of x and y. So put this as dy by dx is equal to y square divided by xy minus x square as number 1, and put y is equal to ux and differentiate this putting with respect to x, so we get dy by dx as u plus x into du by dx. Now equation 1 becomes on left hand side u plus x into du by dx, and on right hand side as we have to put y is equal to ux, so y square become u square x square in numerator, and in denominator x into bracket ux minus x square. Now by simplification, so on right hand side as u square x square remain as it is, and in denominator bracket multiplication you get ux square minus x square. By taking x square in denominator common, we get in bracket u minus 1. By cancelling x square which is common in numerator and denominator, we get term of u square divided by u minus 1 on right hand side. To reduce variable to this differential equation in variable separable, we take u on right hand side, on left hand side we get x into du by dx. Now on right hand side u square divided by u minus 1 and plus u get in subtraction on right hand side. To simplify, we take cross multiplication, as first term numerator has a u square, and in second term numerator minus u into u minus u square, and minus minus plus u as common denominator u minus 1. U square get cancelled, Now we get u divided by u minus 1. So we take term of u on left hand side and x and dx on right hand side. As u minus 1 came into numerator and denominator, you get u as du in multiplication. On right hand side we get 1 upon x into dx. Now to simplify this, I take integration on both sides. Before that, as u is a common denominator here, we separate this denominator to get two terms in subtraction. As first term become 1 and minus second term become 1 upon u and du in multiplication. Now take integration on both sides as 1 minus 1 upon u into du on left hand side and integration of 1 upon x on right hand side. Okay, so simple integration we have to take as subtraction. 1 with respect to u du has integration u, yes, and 1 upon u has integration log of u, and on right hand side we get integration of 1 upon x as a log of x plus c, and finally by putting u as a y upon x we get y upon x minus log of y upon x is equal to log of x plus c. Understand, as y put y is equal to ux, for resubstitution we get u is equal to y upon x, we put in final solution.